So I've gone into the vault and I've dug out another proof of Pythagoras' theorem. That is, in a right angle triangle, c squared equals a squared plus b squared. Now this proof relies upon similar triangles. Now similar triangles are triangles that are the same shape but different sizes. Now the easiest way to create two similar triangles is to take the dimensions of a triangle. Say this one is 3, 4, and 5, that's familiar. If we take all of those dimensions and multiply them by 2, we get a similar triangle that is twice as big. Now of course these are right angle triangles, but that doesn't really matter. The main point is that to create similar triangles, we can just multiply everything in the triangle by some amount. So now that that's out of the way, let's get started. We need to start with a triangle labelled ABC. So here's my triangle, and you can see it's a little itty bitty triangle, and the reason I'm starting with such a small triangle is because I'm going to scale it up. Now, I'm going to create 3 copies of this triangle, and I'm going to do it by taking this triangle and multiplying all of the sides first by a factor of a. So here's my triangle that's been scaled up by multiplying all the sides by a. Now that means that this side here is going to be a times a, which is a squared, spoiler alert. This one here is a times b, and this one here is a times c. I've just multiplied all the sides by a. Now I'm going to create another triangle, and I'm going to do it by taking this original triangle and multiplying all the sides by b. Now this gives me a larger triangle again, and this side is a times b, this side is b times b, which is b squared, and this side is bc. Alright, and now I'm going to create one more triangle by starting from this itty bitty triangle and multiplying all the sides by c. Now of course that means that this largest triangle is going to have sides of a times c, b times c, and c times c, or c squared. Now let's tidy this up a little bit. First of all, these are all a squared, b squared, and c squared. And once we've done that, let's look at the remaining sides and notice that this is AB and this is AB. Those lengths are the same length. AC, this is AC and this is AC right there. And BC is here and BC is here. We have all these lines that all match up, and now we can put these 3 together like a jigsaw puzzle. First, I'm going to redraw this triangle down here. So now that that's redrawn, I'm going to take this one here and I'm going to turn it and put it right there. And now look at what we have. A length of BC here and a length of AC here. A length of BC here and a length of AC here. Now, we can see that this is going to be a right angle. We can see that because this is a right angle, this is a right angle, this angle and this angle are the same. This angle and this angle are the same, which means that these two must add up to 90, and that one must add up to 90. Finally, I can take this and I can draw it in there. And look at this beautiful thing. We have a rectangle here. It's not difficult to figure out that these are right angles as well. And we have this length, a squared plus b squared, is equal to that length right there, c squared. Here we've used similar triangles to prove Pythagoras' theorem.